Hi viewers, welcome to LMS Solution. Today we are going to see about power factor correction using SEPIC converter, and also in this video we are going to see about the open loop control and the closed loop control for power factor correction. So this is a model for open loop control. So it consists of source voltage, that means AC voltage and diode bridge rectifier, and then so this is known as SEPIC converter, and this is load. And this SEPIC converter going to be controlled in the manner of open loop, and then here we are going to provide 0.3 duty cycle, and here you can measure the source voltage and source current, and here you can measure the load voltage and load current. So here we are using the diode bridge rectifier with the load, right? So that going to act as a nonlinear load. So what will be happen? The source current nature going to be non-sinusoidal because of that nonlinear load. That means it will draw more reactive power from the source. Okay, so because of that the source current going to be non-sinusoidal. Okay, so I'm going to simulate this model in open loop, so you will see the result. So here you can see that this is the result of source voltage and source current and load voltage and load current. So here we are not control the load voltage, okay, and also we are not control the source current because it will be operated open loop. So that's why the source current nature is non-sinusoidal, and also we are not regulate the output voltage because it is going to be operated in the open loop. Okay, next we are going to see the THT of the source current. So further go to FFT analysis and then go to source current. So I'm going to analyze for a single cycle. So here you can see that we are getting around 66.24 percentage. Okay, that means normally as per IEEE IEC standard, this should be less than 5 percentage. Okay, so source current THT should be less than 5 percentage, then only the power factor also going to be near to unity. Okay, but here you can see that the THT is around 66.2 percentage. So we need to improve that. That means you have to reduce the THT as well as you have to improve the power factor, because from that source voltage and source current you can see that both are not in phase. Okay, so that means because of that load draws load, and the diode which rectifier draws more reactive power from the source. Okay, so this is a problem. So in order to avoid this problem, we go for closed loop control, the same circuit. So here we are going to use closed loop voltage and current control. So it having two loop, outer loop and inner loop. So outer loop we are going to use voltage controller concept. So inner loop we are going to use current controller concept. So here we have to measure the load voltage and going to be compared with the reference voltage, and it going to be processed via PI controller. So the PI controller will be generated the reference current in the form of DC. Okay, so and then it will need to be converted into AC form. So for that we need to measure the input AC voltage. So from there you have to find out the unit voltage vector template. Okay, so that going to be multiplied with that reference current from the PI controller. So here you have the reference current in the form of AC, and then you have to compare this reference current with this current, diode rectifier current, and it going to be processed via again PI controller, and it going to be processed via PWM generator, and it going to be generate the pulse for this IGBT in order to make the source current sinusoidal, and also increase the power factor of the system, and also reduce the THT of the source current. Okay, so this is a closed loop control of power factor correction using SEPIC converter. So let me check the result of this system. So I'm going to simulate this model. So now you can see that the nature of source current, right? The source current goes to sinusoidal, and then you can see the response of the load voltage, right? It going to be maintain around 100 volt, because here you can see that we are provided the reference voltage we have provided here is 100, so it maintain at 100, and also you can see that the load current is maintained at around 2 amps, right? So So here you can see that the source voltage and source current having in phase, right? Both are in phase. That means the power factor is almost unity. So next you have to check the THD of the source current. So here I am going to check the THD. Here you can see the THD is around 3.72%. Okay. So when we are not using closed loop control, when we are using open loop control, the THD is around 66%, right? So when you go with the closed loop control, like in outer and inner loop control concept, that means dual loop control concept, so you can see that the THD is almost reduced to 3.72%, and also it will be the standard of IEEE and IEC for that source current THD. Okay, and also here you can see that the source current and the source voltage are both are in phase. That means if both are in phase means the power factor also almost improved to the unity. So this is a working of power factor correction using SEPIC converter with the dual loop control. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.